So let's move on to the combinations of resistor. What are two different combinations of resistor? Series and parallel, right? So we try to wrap it up as fast as we can, and we'll move on to even more interesting topic, the same type of circuit combinations with cells. So up to this point in our last class, where you had a minor doubt if it is about difference between EMF and potential difference, we are going to sort it out. But first, the series combinations of resistor are like this. These are two resistors in series connected with a supply of potential or voltage. Alright, let us say this is resistance R1, this is resistance R2. What are we trying to find? In series combination, what would be the net resistance? So how do you find it out? Voltage V, this current I flows in this circuit because current do not have any other path to follow. So whatever current this source is providing, the same current is going to pass through each of the resistor, right? So what will be the potential drop here? There will be some potential drop here and there will be something here, but the potential drops would be in such a fashion or such a manner that the total potential drop V1 plus V2 will always be equal to the applied or the given potential by the source. That means V is equal to V1 plus V2. This is how potential drops take place in a series circuit. So what is V1? We know according to Ohm's law, V equals to IR. This is a universal formula which we will be using in many different ways. Here V1, potential drop across resistor R1, is the current flowing through resistor R1 into the resistance of resistor R1, right? So IR1 plus similarly IR2, which is IR1 plus R2. If R is the total resistor of the series combination, then what should be the V? If I make an analog circuit, exactly a replica of this, the circuit would be this R connected with V, right? This is the overall circuit, overall resistance of that circuit. So this V should be equal to the total current which is given by this circuit into the total resistance of the circuit. That means R is equal to R1 plus R2. So this is the formula which we will be using while doing the series combination circuit, right? In case of parallel combination, what is parallel combination? Resistors connected like this, having what do you mean by this? If I make a circuit like this, or if I make a circuit like this, they are all in parallel. So basically the point that all these four resistors are in parallel is basically what? This voltage is equally given to all of these components. What is the term component? See, in our coming chapters like EMI and AC and whatever, there will be conductors, there will be inductors, capacitors and lot of stuff. So all these will be electrical components. Here voltage is given equally to all these components. So this is called a parallel combination. We'll do it here. This parallel combination of two resistors is connected to our same supply giving V volts. I am not using the word E anywhere right now. I'll be using it in a while. Given it to R1 and R2. Alright. So as I just explained, voltage will be equal for both. Here potential drop or potential given to this resistor will also be V. Here also be V. So what is changing? The current which was provided by this source, from which path will it flow? See, this current, from which path will it flow? From this path or that path? From both the paths, whatever. But the proportion of current will depend on the value of resistance. Remember a sentence, current seeks the least resistive path. Yes, the current seeks the least resistive path. So more resistance flows from more current flows from less resistance. Alright. So this is how current flows, and current got distributed into different parts. So total current, instead of starting from V, I'll be starting with total current. It got divided into two parts, I1 and I2. What is I? Okay, we'll go to this point later. What is I1? I1 is V upon R. V is the voltage given to resistance R1 upon what is the resistance of resistor? R1. Similarly, V upon R2. What is I? I would be the total voltage upon total resistance of this circuit. So it would be V upon R1 plus V upon R2. Take V common out and cancel it out. You will be left with 1 upon R equals to 1 upon R1 plus 1 upon R2. This is the formula for resistors in parallel. Now when we do the circuit of, don't change anything, when we do the circuit of cells, what is cell? This is the cell.